Here we'll cover another basic graph called a linear graph, a function that involves x to the first power. On the left we have the graph of y equals x. That's the most basic linear function available. Notice how in this graph we have two arrows, but they are pointed diagonally rather than straight left and right. However, when we look to the domain and the range, we will treat them separately. So if we're trying to find the domain of this graph, we look only at what's happening on the x-axis. We can see on this graph we do have a diagonal arrow, but it is pointed left. Because we have this left arrow, left on the x-axis represents negative infinity. We also have a diagonal right arrow. We know that diagonal right arrow represents positive infinity. Therefore, we still have a domain of negative infinity to positive infinity. The fact that the arrows are diagonal does not change the domain. Bear in mind that the domain is just a set of numbers that are allowed on the x-axis. Since we have no interruptions on the x-axis, we still have negative infinity to positive infinity. Now let's have a look at the range. Let's remind ourselves for the range we're looking at the y-axis. And we can see that on this graph there are a lot of different y values possible. But also notice that we have a down arrow. Even though it is diagonal and down, now that we're looking at the y-axis, we take note that this arrow is pointing down. Now, because that arrow is pointing down, let's imagine what would happen to y if we went further downward. The numbers would get more and more negative, and eventually you could say that it's going toward negative infinity because you'll get really, really high negative numbers. By the same token, you may notice that we have an upward diagonal arrow here at the top of this graph. Imagine if we continued further on upward. Again, thinking about the y-axis, the y values would get higher and higher and higher, and you could say that this function will also go toward positive infinity. Now, when we write the range, we always write it from the bottom to the top rather than left to right. So on the bottom we have that down arrow, and that down arrow represents negative infinity. On the top we have an up arrow, and that up arrow represents positive infinity. We'll place those inside of parentheses. Now, for the third question, f at 2, let's circle where 2 is located. Draw a dotted line going up to the function. Place a red dot where we intersect the function. If we read the y value at that position by drawing another dotted line, we can see the y value at that position is 2. So we'll say f at 2 equals 2. Now let's look to the graph on the right that says y equals 3x minus 3. We've made a few changes here. First, notice that this line appears steeper. The reason why the line appears steeper is because of this modifier in front of x, that's the 3. So this 3 represents the rate of change. We'll talk about this in another video, but think of the rate of change as noting how steep or shallow the line is. Also notice that on the original graph, the line passed straight through the origin at 0, 0. However, this new line does not pass through the origin, and that's because of this negative 3 modifier that comes after the 3x. We'll talk about this when we talk about transformations later on in this unit. However, this negative 3 we can think of as a vertical shift. If you look closely, it seems like this line has been shifted downward and made steeper. The 3x has made it steeper, and the negative 3 shifts everything downward. However, when we try to look at our domain, we might notice that we still have a left arrow and a right arrow. This will be the case anytime you have a linear function. So this linear function, because we still have the left arrow and right arrow, will have a domain of negative infinity to infinity. However, also notice that we have an up arrow and a down arrow. We have an arrow pointed down and an arrow pointed up. It's a bit steeper than the previous line that we had on the left side of the screen, but that doesn't affect the domain, and it also doesn't affect the range. Because we still have the down arrow and up arrow, the range is still negative infinity to infinity. This will be the case for any linear function. The domain and range will always be negative infinity to infinity. Now we are asked to find f at negative 1. Now let's find negative 1 on the graph and place a mark. Negative 1 will be halfway between 0 and negative 2. I'm placing a mark at the negative 1 in red, and we may notice that this picture of the graph does not intersect negative 1 because the line doesn't extend that far. When the line does go off the graph, what we can do is go back to our function 3x minus 3 and let x become negative 1. So everywhere we see x, we replace it with negative 1. So imagine that x was negative 1. We would have 3 times our negative 1 minus 3. 3 times negative 1 would give us negative 3, and then we would subtract 3. Negative 3 minus 3 makes negative 6, and so we'll say f at negative 1 equals negative 6. So this is how we find domain and range and evaluate linear functions.